Good afternoon, everybody. And thank you for joining me. My name's Brierley. I'm the head of digital engineering at Laing O'Rourke, and this presentation is on how we've created a crane simulator using the Unity platform. I'm just going to break this into sort of three chunks. I won't spend too long on the first two, but they're important context. So, a little bit about the construction industry, how we at Laing O'Rourke are trying to challenge and change that, and then how we within our digital engineering team have created the crane simulator using the Unity product. So it's a fairly well-known statistic that in the region of 90% of construction projects worldwide are either late or over budget. So the good news is that there's plenty of opportunity for us to make improvements. We don't have the best of images within construction, and you put that into the context of a number of the workforce and the experience that they hold leaving the industry, coupled with not being able to attract the same sort of numbers into the industry against the backdrop of a changing environment. So we're going through a digital revolution. So not only do we not have a strong enough supply of the skills we require, we are fast learning that we need to introduce new skills. And you'll hear people from within the sector talking about data analytics, developers, programmers, and data scientists that we are looking to introduce to the industry in order to help us with respect to productivity. There are many reports dating back as early as the mid-90s from Latham and Egan around where construction could make some vast improvements. And more recently, the Mark Farmer review, with the slightly drastic title of Modernise or Die, points out some of these key areas of opportunity. So we have low productivity rates, a great deal of fragmentation over the design and supply chain, low margins, high risk, and quite frankly, a lack of collaboration and improvement as a whole. So I've spoken about the poor industry. You put all of this together, and it's quite an interesting, challenging time for us. And it's nothing that we don't know either, which leads me to my next slide. So these are well-documented and well-known facts. The question we ask ourselves is then, what are we prepared to do about it? At Laing O'Rourke, we've been investing quite heavily around how we might just challenge and change both ourselves and the projects within which we work. There's a quick note from our chief executive and owner. So we work for one individual, Ray O'Rourke. We are the largest privately owned construction company within the UK. It's about 3 billion turnover, somewhere in the region of about 4,000 employees, and we have our own direct labour force. We have a strong reputation around innovation, and we have a particular mission that we are driving towards, and this is underpinned by something called design for manufacture and assembly. So you'll have, perhaps if you were in the room earlier, you will have heard shop architects talking about how they are looking to bring automation into some of how they go to work, and that's very much been the case for ourselves. I said we're privately owned, and we have a number of vertically integrated in-house brands, which allows us to be quite lean and agile with respect to how we can influence the partners that we are working with. So these brands include Crown House Technologies for our MEP installations. Select is our in-house hire. That's all cranes, cabins, lifting equipment. And then to the far right-hand side, Explore Manufacturing. And I'm just going to spend a moment there because that's quite key to our design for manufacturing assembly approach. So out of this factory, this was a £100 million investment that came from Ray O'Rourke himself. It was built 10 years ago. And largely this has been created around a product set, which is just across the bottom of the screen there. So we are looking to create that kit of parts, influence the design, and then use those in the way that we go to work and construct our projects. And I've got a 2-minute video here just to give you an insight to that very facility. So hopefully you'll get a sense from that video there to the investment that our owner's prepared to put into going to work differently and the scale of that facility. There's a couple of slides here I'm going to use just to help me articulate a little bit about some of the key enablers, and then we'll move on to the consequences of this kind of change of approach. So this is Crossrail. We're doing 2 or 3 stations and some tunnel runs with respect to this project. I think it's one of the largest projects currently in Europe for rail infrastructure. You'll see the size of the components to the left-hand side of the screen supporting the finished platforms. So these are all from a manufacturing approach, right? So all the gains in quality you get by working in a factory environment, you want to make sure that when you get these to site, they fit. So the last thing we want to be doing is unpicking all of our hard work. And that's true of those larger components that are supporting the slightly smaller platform finishes there. Again, this is Crossrail, and you'll see here, and it's repeated in the video shortly, the component set that we then take into the structure that will support those platforms. So as users of such a rail system, we won't see this, but there's the large tunnel, and you can see there the small team of operatives putting into place the structure that will hold the platforms. And then this is a snapshot from Leadenhall, or the cheese grater as you might know it, which is in the centre of the city of London. We're about 50 stories up here. And rather than installing these bits of steelwork piecemeal and doing various follow-on trades, what we're doing is we have got these manufactured, sprayed, and then they are transported to site. And then everything then starts to come down to hook time in the lift. And so we do as few as few tasks on site as we can by moving the work and therefore increasing the quality by taking things into a more controlled factory environment. I just want to point out two things, right? So there's a key enablers are being able to influence the design early because you're now taking a product-led design approach and spending specific amount of time on the detailed design such that the geometric fit is what we expect when we get to site and that we're not unpicking the hard work that's gone into the manufacturing side of things. The consequence of working this way is that we now spend a lot more time perhaps focusing on the methodology. So not only have we got to be able to get these components into place in their finished state, but we have to be able to navigate these around a changing construction environment. And this puts an awful lot more thought process and critical path, if you like, on the lifting and the manoeuvring of these products. So there's a short clip here, and I'll just ask you to consider some of the movement of these component parts. So as you can see, a far greater focus on the movement of those component parts, and hopefully you've got a sense of scale as to how some of those look. So I mentioned I'm the head of digital engineering at Laing O'Rourke, and in a way, in order to try and increase some productivity around our projects, we look to digitally prototype as much of our projects as we possibly can prior to building them in reality. And we do this through a number of ways. The team that I lead is focused predominantly across these three areas. So we spend a considerable amount of time trying to secure work, and we focus on de-risking and understanding the complexities of the projects at this point. So we'll do some work around visualization, methodology, and quantification. Once we secure a project and we go into delivery, we have a team that focus on something called Level 2 BIM, which you may or may not be familiar with, and some of the other presentations have spoken about BIM, Building Information Modelling. This is responding to government and/or client requirements, setting up an environment on a project whereby we can collaboratively work in a 3D environment with our design and supply chain, and look to utilize some of these models to other use cases. We have a team that kind of sits between the two, a central modelling team, and I'm going to focus on this team because this is where we get to the crux of the presentation. And we have used various different bits of software for a number of different applications over the years. I'm going to focus on augmented virtual reality and the use of Unity. It's probably worth pointing out that around about 2008, we got our first bit of antiquated kit that looked like a small keyboard and a camera held together with gaffer tape, but it sort of worked for us. You'll see prior to 2015, there's a smaller number of use cases, many of which were less successful than others, and I've got no issues with that. I'm quite happy to fail fast as long as we continue to learn about what it is that we're trying to achieve and where the application might be. Against that timeline, I'm going to focus upon the crane simulator and how that's been taken into our lifting academy. There's a key point I want to raise here, and it comes back to that skills report that I mentioned right at the start. So we added Derek and Grant to our team post-2015. They took a bit of a gamble on us as developers, not familiar with the construction industry, and I certainly didn't ask permission when recruiting these individuals, but they've been very, very fundamental and valuable team members since. And they've brought a skill set that we were otherwise struggling with. So as engineers and technicians, we don't necessarily, certainly my generation, have a developing and coding and data kind of background built into us. It just simply wasn't part of our training as we went through our learning. And I think the guys here are seen praying to the modelling gods that Reflect will stop them having to spend all of their time optimising models. They assure me that's 60% of their time, so I'm looking forward to some productivity gains myself when that software comes available. So what's key with any kind of application is that you understand the scope. The scope here is that we have a crane operator working in isolation. We'll have another member of the lifting team, usually out of sight, hooking a load, and then someone else, another member of the lifting team, on the project somewhere, perhaps in sight, perhaps not, unhooking the load, ready to put that into position. And this team can look different from one project to another, and just bear in mind those components that I showed you in the videos earlier. If we put that into context of a project, you'll quite often find that there's more than one crane at a time, and the communication between these drivers is fundamentally key, as shown by the fact that in plan here, they will oversail. And in addition to communicating with each other and doing concurrent activities, this is how that lifting team might look on a project. So down at ground level there, you'll see the back of the wagon, and we'll have an individual from the lifting team hooking the component, not necessarily being able to see the individual who's going to be in receipt of that component. And it's not always that that individual in receipt of the component will be in the field division of the crane operator. So I think on one or two of those videos earlier, you saw us dropping some large components through a mole hole. So the methodology would have allowed for us to drop those components. And again, the communication is all now verbal, and it's fundamental that this team understand the constraints and the perspectives from each other such that this is done safely. If we come back to this view here, just to try and give you an idea as to what that looks like in reality, here's a photograph from the cabin of that very crane on that project. And you might just be able to make out that orange dot. So that will be a member of the lifting team in receipt of that component, and they're just unhooking that load, probably not too far from where that's going to be installed if it's not being installed in that very operation. You might notice that we're about 4 or 5 floors up. So the lower those floors are, the greater that distance and the harder it's going to be at sea. And you certainly can't see beyond the edge of that slab there in order to see where the lift was being hooked in the first place. So fundamentally, we're talking about blind lifts here, and the communication being so important. You might also notice that this is a relatively quiet and clean-looking site. And that's, again, another one of the advantages from a design for manufacturing assembly approach, that we managed to reduce the number of workforce on site by focusing on these key operations. So if we go back to the context of the team here, the crane simulator started with some development around the crane operative's perspective first. And there's a short video here I think Grant, one of our team members, is going to do a bit of narration around how this came to begin.
So I'm not from a construction background, I'm a programmer. So I've come from a completely different background, and I was brought into the company to sort of develop applications like the one for the Google headquarters. So we've made a crane simulator, we've made sort of inspection modules for health and safety, training applications, that sort of thing. And it's to immerse people in the environment before they go there, really. Gaming has come sort of a long way in recent years, and it pushes VR and AR technologies forward. So we use headsets which are used with gamers, and we use a gaming engine called Unity to develop platforms to run the VR applications. with training and simulators, a lot of people are using VR because they're immersed in that environment, they can't be distracted, and it's a lot better tool to use than just sort of a tablet or a PC. Recently, I saw a video online of someone in a completely different country controlling a crane with VR controllers, and that's where I'd like to be heading, where people don't have to go up a 100-foot crane. They can just sit in the office, use the controllers, they're in a safe environment. If anything should happen to the driver, they're all the way up there. Instead they'll be in the office in a better environment.
So I'm not entirely sure if you noticed there, but just towards the end there, that was an extract from a project that we secured. It's the new Google headquarters. That's in central London, adjacent to King's Cross and Pancras Station. And key to us understanding our own risks and then conveying to the client that we were the right people to appoint to work to, was being able to take our design for manufacturing assembly approach and lift those components safely whilst operating next to a live railway, which, as you can imagine, was quite a key requirement. So that was the early part of the simulator, and then the team have extended that with a focus on the rest of the lifting team. So there's a short video clip here. There's no narration, but a couple of bits of text to help you. Just from the operative who is unhooking the load, and then again the individual who is blind and out of sight to the rest of the team who will be taking receipt of that load. Okay, so that will give you an indication as to how that functionality was starting to build in for the rest of the lifting team. So this more recently has all come together and formed part of the key training material that we have built a training academy around. I'll make no apologies for the fact that this is very much function, if you like, over visualization. So we're trying to make sure that we are just building in the right level of functionality and hold points and questions and test points, if you like, within the software, in order to make sure that we're comfortable, we're getting the right feedback from our lifting teams, and they're focusing on the training points that we would like them to. Some of the key points that we've had from this is that the environment's fairly well simulated, and that it's really improved the communication across the lifting teams themselves, but the lifting teams across other projects. Now, if you put that into context to some of the stuff I shared with you earlier around the experience and the skills leaving the industry, that's a really usable knowledge base for us to help build upon and make sure we've got the right workforce in order to take the approach that we're looking to do so. There's a short video here whereby you'll hear from some of the operatives who have used the training material themselves. So there's a little bit of a corporate induction, but For me, the success of this has been the feedback from the operatives themselves that comes a little later in this video.
Laing O'Rourke is committed to ensuring that its workforce is equipped with the necessary skills to deliver exceptional industry service, reflecting the sector-wide momentum behind DFMA and off-site manufacturing, with an emphasis being placed on larger and heavier lifts. Currently, the demand for highly skilled advanced slingers around the country exceeds supply due to an increased reliance on lifting operations. As a result, this is leading to poor productivity and a lack of technical competency and safety within our industry. Delivered by certified trainers at our dedicated training centre Incent Needs, the two-day course is designed to equip our slingers with both enhanced practical and theoretical knowledge to deal with more complex products and lifting operations within busy construction sites.
Well, 1977 started banking a crane. There was no courses or tests in those days. Everything was got through experience, like, you know.
I've been slinging for about 25 years now, and as a slinger you think you know pretty much everything after 20, well even after 10 years I'd say. But this course is industry changing. It's fantastic.
I have learned a bit, to be quite honest with you, which I didn't think I would, but I have.
Lowering off in 5, you've got quite a way to come down here, mate. Coming down, as it keep coming down, slowing down into 3 now.
We've tried to develop the software to mimic what it would be like to sit in the cabin of a crane. So it would have a hook camera, have a SME system, and the specific one we're using for the lifting academy has a blind lift. So there's a banksman and there's a crane driver. The crane driver can't see the load they're lifting, so they have to rely on the banksman to safely lift the load into position.
You actually feel as if you're sitting in a crane, driving it, like, you know. Yeah, very good.
I'm not one for computers, and I enjoyed it. It was good. It was quite real.
It gives you an insight of what the crane driver can see as well. Rather, I mean, you haven't got to go up the crane and have a look at this VR, this virtual reality thing, because, you know, you can see what the driver sees.
I found that meeting all the other slingers from different trades that are out there, they've all come in and they've all picked stuff up themselves. You very rarely get slingers together and talk about what they do as different jobs. So I've learnt off some of them slingers, and hopefully they've learnt off me.
I've got like 12 years experience, but I've come to this session today and yesterday and today, and I've still learnt stuff.
So I think for me there, the feedback there from the operatives is fundamental. If we can continue with the various different developments and ensure we get that level of engagement and connectivity and feedback from the operatives, then we're doing something right. So just to summarise there, I thought it was important just to share a little bit of industry context for you, the opportunity for us, and the opportunity that might exist for a number of you in the room to, if you're not already in the AE space, to seek out perhaps a different opportunity that you might previously have been aware of. How we at Laing O'Rourke are trying to challenge and change some of those industry norms, and where the team that I'm lucky enough to have support me have developed the crane simulator using the Unity platform. There's one or two other areas where we're now starting to take this, and we're getting a bit more traction around it, so this is really quite a pivotal period for us, and I'll just briefly show you those. So there's risk assessment method statements, and we're using the platform predominantly in 3 parts here, whereby we create a creator, which gives us a bit of a framework from which other people can use this app and make their method statements. So typically this would be something that a project engineer would take hold of and create on a project. And then there's various controls that we're introducing into this so that we can guide the workforce around what it is that we want them to look at. And we have quite a diverse workforce, and so various different languages we're looking to bring into this. There is also the inspection and training of temporary works. So this is something that's actually up for an industry award at the moment in the UK. So we're waiting to hear on that. And some of the features that we're building here are, again, it's an immersive environment We drop some two-dimensional drawings in, which we would more typically perhaps use within a method statement or a training module for our engineers and workforce, and then we can start to put in reason-based placements to test learning and understanding, as well as some key annotation and the ability to mark someone's success through the tool. And then something else that we develop more as proof of concept, really. The presentation before spoke about construction documentation, and contractually and historically that's largely around two-dimensional drawings specification. From my perspective, handing over a set of red line marked up drawings or blueprints isn't a particularly productive piece of work, or is it all that useful? Rarely do I believe that they are utilised. So there are some other products on the market that do something similar, but the guys basically have developed an app whereby we can put our own blueprints, if you like, in a 3D form onto an app and then start to host key progress photographs. And we're looking to get some feedback from one or two of our clients as to whether or not this would be a better way of handing over completion documentation to them. That pretty much brings me to the end of the presentation. There's various different ways there on screen for you to stay in touch with us. Otherwise, I'm happy to take a couple of questions. And I've got my technical colleagues with me if you ask me anything about Unity itself. Otherwise, thank you.
I've got a question. You did mention that 60% of the time was prepping data to bring it into Unity. Could you explain a little bit about that process and where you're taking data from, what applications you're taking data from, and how you process that data, and then how you, when you have updates, how you handle those updates when processing that data?
Yeah, I think it's probably a similar question to one that was asked previously. It's I know the team are quite excited by what Reflect might potentially bring. If we're in a building-based project, it's largely around the Autodesk suite of tools, so Revit would be fundamental to that process. If we're in infrastructure, it's a Bentley suite of tools, and those models primarily, unless we influence them early, aren't created to bring into a platform such as this. They may well be put together for a drawing output or with some manufacturing detail in mind. And so currently, as the team told me, they will spend a lot of time stripping down and optimizing those models so that they can be more user-friendly within the Unity platform themselves. Yeah, go back and repeat the process.
So it's a lengthy process, even when you have, you don't just bring in deltas, you have to bring in the whole model again. And
yeah, Derek, is there anything you wanted to add, perhaps, or?
We get all different formats from different departments, and most of the time will be I'll ask them to hand me over the Revit file or the Navisworks, and I export it into FBX. Mm-hmm. And most of the time I will strip it down the model using 3D Studio Max. And recently we are starting using Pipsy from Unity. Okay. And that helps a bit, but again, I still need to bring the model back and forth between 3D Max Studio and Pipsy again, just to get exactly what I want. Mm-hmm. And like you said again, if you want to update the model, yes, the whole process will be repeated. And hopefully the Unity Reflex thing will help me out a bit with the updates.
So that's something you're looking at adopting, but you're not using yet?
No, but okay. You will soon trying out the Unity Reflex as soon as it come out.
Yeah, correct.
And you don't bring any metadata in, you're just bringing in dumb geometry?
Yes, at the moment, yes.
And would there be a use for you bringing in metadata?
Yes, it will be really useful for us if soon we can use the metadata. Next, for example, we can implement the build sequence using the metadata. Yep. So we can have like object turn on and off based on what timelines of the build.
Mm-hmm. So you could be linking, you use Navisworks, could you be linking it to Timeliner in Navisworks so you have the construction sequencing?
Yes, I think so. We're looking into it once it launches. So I think Unity will give us some trial period and just to let us to try this.
So it was an interesting point that previous speakers spoke about using the right tool for the job. Mm-hmm. So we'll have a suite of software. We'll use So there's been some master BIM trials around the construction sequencing side of things. We've used Synchro a fair amount, and Navisworks. So it really is a case of the right tool for the job, depending on what you're trying to achieve. With regard to bringing in the metadata, I was quite keen to see whether or not the configurator that I saw in an earlier presentation might lend itself to a future extension of the lifting tool, whereby if the right metadata surrounding, say, for example, the weight and the lifting capacities of the components and the cranes can be used to help us with respect to just testing various different scenarios.
Yeah, it becomes more of a simulation tool than just
very
a
much
visual clash detection
situation. Yeah, so fundamentally at the moment you'd say it's been largely successful around transfer of those skills and that knowledge base and clear and effective communication, which don't underestimate because of the blind lifts themselves and the complexity that we're now adding to the hook time in the lifts by our DFMA approach.
Okay, thank you.
Thanks.
Thank you.
Hi there. So you said how, in one of the slides you referenced someone else who had said that the industry can be kind of slow with innovation and stuff.
Yes.
And so I work in a separate industry, but also an industry where it's not a gaming industry where we're trying to use Unity. And I wanted to know how you sold to the company the use of Unity, because obviously it must have been quite a different an idea. It's like, oh, let's use this gaming engine.
Yeah.
To use it. What were the points you used to try and
Yeah, and I didn't tell anyone. I waited in the team till the team was big enough, and then I snuck Grant and Derek in. To be perfectly honest with you, I'm very lucky. I'm a bit more genuine. I'm very lucky. I work for a company led by an individual. So my challenge is not how do I push this within the organisation. It is how on earth do I keep up with the challenge and the demand. All right, so that's a wonderful place to be. I didn't ask permission, nor did I have a job sheet to go out and try and recruit. It wasn't easy trying to find a Derek or a Grant because we weren't entirely sure what we were looking for initially. I guess if I'm being perfectly open and honest with you, is we took a gamble on them as much as they took a gamble on us. Sometimes you just have to follow what you believe in. So we were playing around with the software and not making any traction. And so you have to recognise that if you haven't got the right skills in order to really harness what's available there and the promise of what could come from here, that you take a bit of a punt. So my role is to try and create an environment for the guys to exceed, and then we have to try and deliver upon that. And all the while we do that, the organisation supports us.
I guess to reword the question, what was it that kind of attracted you to the idea of using Unity to be able to make these kind of tools?
I think we're quite a curious bunch. So we looked at various different bits of software. We weren't necessarily getting what we needed or felt we needed from the software that we had. So we started to look outside of that. Bits of software like Fuse or Unity, we were starting to add those to our landscape. What we have to be mindful of, though, is you could spend a lot of your time looking at everything that, something gets launched each week, it feels like at times. And so you have to keep that problem. So the reason why I sort of scoped the problem was, what problem are you trying to solve? Now, what do you require? What tools do you require in order to solve that problem?
Cool, brilliant, thank you.
Okay.
Hi.
Hey.
I have one short question. I have seen this. The scene is with complete physics or without physics? Because I have seen if you're lifting something, your ropes is it's not giving the transaction, or you can say the real physics, what it has to give. Yes or no? No.
I think you probably know the answer to that, but
yeah. Thank you for putting me on the spot.
Done. The next question.
All feedback's good feedback, Derek.
Right. We have implemented some physics on over the time on the crane simulator, but my feedback is they really want to focus on communications. So what I asked to do, or what I think is we put it on the table first, is the ability to let the banksman and the crane driver to communicate first, and then later in the future, I will start updating all the physics and all that and make it even more realistic. So that is the plan. But yes, what you see on the videos, yes, I had to get something just to proof of concept so they can buy into this technology. So, and then I can start sort of like involve along the time. So I've been putting weather simulations, putting some others like features, questionnaires, tests in the end. So this is what I'm planning to do in future.
Okay, thank you. And the next question is, you're talking about the communication. So the main emphasis or focus is on communication. Are we also talking here about the real hardware of the crane, or it's just a virtual world that we are only like talking about, like something from the crane we are getting via PLC or like OPC servers or something that is feeding the Unity that's, you know, coming the real crane data, or it's just complete virtual world?
No, virtual world. So I think to the earlier question one of your colleagues asked about the metadata that's coming across. So it's what's interesting is you do something, you show it, and you create a bit of interest, and that's very much what we're trying to continue to work upon. And when you get some engagement, particularly, I mean, I'm particularly proud of the feedback you got from the banksmen and the slingers through that video. They start to, that curiosity continues, and they start to ask the questions, right, well, what if you did this, and what if you did that? So I think we're not trying to sell something within the organisation. The challenge now is just how do we keep up?
Okay, thank you.
Great stuff. Thanks, everybody.
Thank you.